Welcome to today's webinar for UPG and SciTech in their April mega month of training. Today we'll be looking at GNSS baseline processing in TBC. Given it's a training session, we thought we'd start with the field capture and a few things just as pointers. My name's Stephen Shepherd. I work for Trimble as a geospatial solution specialist in the APAC region, but my area that I cover is more often than not is Australia and New Zealand, with a few extra things in there. So my role is to assist the distributors in training, keeping up to date with products and anything else, sometimes things like this. So what we'll get started with, I will into this one, and can I move this bar? That's going to be, unpin the toolbar, move. This does not want to move at the moment. Okay, figure out how to jump tabs. I can't actually get to the tabs behind it. You got any advice there, Ross? Sits in front of my tabs that I've got set up. All right, we'll have to go with it, but oh, it's disappeared. Thank you. Okay, so if you're looking for some information around GNSS static surveys for post-processing, like we're going to run through today, today's session will be around static, which are longer observation periods, rather than looking at something like PPK, where it's the equivalent of doing your normal rover survey, but you're actually doing quite short occupations on those points, or something where it's being logged as an actual trajectory and you get a little breadcrumb feed of the entire route that you've passed through. So a couple of things for the Australian market. The ICSM, Committee on Surveying and Mapping, they put out a document called the Special Publication, and that is around how to conduct different types of surveys. Now, it's very detailed, and it's also quite conservative in some of the things it would suggest. So this one, Guidelines for Control Surveys, is a good one to have a look at. It does give you some guidelines. Let's look at static surveys for the time period and the equipment that you should be using as well to try and achieve a certain survey uncertainty, which is always at 95% we're reporting these at. So if you wanted to have a look here, it's quite a good place to go. But as I said, reasonably conservative. I think we can get similar results with shorter timeframes in some of the newer processing that we have on board with TBC, but that's sort of the go-to gold standard. One of the other places to have a look at, which is really well documented as well, and for a complete end-to-end workflow with a focus on TBC, is the Department of Transport and Main Roads in Queensland. They use TBC for their GNSS static surveys and control surveys, and they've put this Business Centre 5.0 guide together, and I'll just bring up a little bit of it here. And it runs through that they run a custom ribbon, so it talks a little bit about that. We probably won't get into that in this session. Also, we'll just focus on the actual processing in the default ribbons, but how to create network diagrams, importing the data, fixing and into the adjustments, and a lot of the science behind GNSS as well that we wouldn't have time for in a 1 hour session, but is really a very detailed amount of information in here. And because it is focused on TBC, it's like a mega tutorial. So you could take the tutorial documents from the Trimble Business Centre tutorial site and have a look at that as well. Okay. The other one, just pop back again, to have a look at is the Trimble Business Centre Bulletins page, when we did some reworking of the baseline processor, we released a white paper on that. So it's the modernised approach for GNSS baseline processing. And that goes into a lot of detail around what we're actually doing. It does also, one thing that comes up quite often from a customer perspective is how long should I be observing for? And this has a little bit of a ready reckoner for certain baseline lengths. Now, that also, you need to still meet the government requirement. So that might be, if you're doing a survey for transport and main roads in Queensland, that you would have to adhere to their particular advice on timeframes. Okay, so we're going to have a look at a couple of things that we can do for the logging. Now, if you were doing a really wide area static campaign, always make sure that you use a log sheet, because this just cleans up that data entry aspect. When we get to TBC and we are entering the data, there is a screen called the Receiver Raw Data Check-in, and this allows us to go through the data and just make sure that it's fine. And if we've got really well booked GNSS log sheets, then we can pick up any blunders or mistakes, hopefully, and correlate that to what was done in the field. There's a few different ways of setting up to log with a receiver though. We can either be in Trimble Access, which I'll jump into in a second. We have a really simplified app called Trimble DL, which the DL stands for data logging, and that's available on any Android device and I think iOS as well. And that just allows you to Bluetooth onto the receiver and start a static logging session. You can put in the amount of time you want to log for, the update rate, so how often you've set the receiver to log at, and the height and a little bit of description. I'll just bring that up on the screen here. So Trimble DL, really easy, nice clean interface, just gives you which receivers you have connected to before, and it remembers them, remembers some survey styles that you create, and then when you get into here, you just create the point that you're logging at. You can see a nice quick sky plot of what's actually occurring on the receiver at the time, and then you get a feed out. You can see the logging files that are actually existing on the receiver at the time, and it's quite nice. You're able just to leverage the email that's embedded on your phone and directly email those back to the office as well. So out in the field, you could have your survey manager with all of the information before they even before you even got back to the office. So that's quite a neat one to be aware of, because for static campaigns, you don't always have a dedicated controller, but you should generally have a phone or something there as well. Now, so if we didn't have Trimble DL and we didn't have an access controller and we were just taking a receiver out, clicking it to start recording and using our GNSS log sheet as our method of recording where it was, what time it started and the height, then we could configure the receiver just to automatically log each time we switched it on. So here's a receiver I've just borrowed for this session to talk about. When we're in the web user interface, we have a lot of different controls that we can set up quite easily. One of these is the data logging. At the moment, I've just got this sitting here default. But if I click on it, we can schedule how often this is going to occur. So is it going to occur daily, once, continuously, like a cause site, or always, which means every time I switch it on, it starts a logging session. So this makes it quite easy for people to just jump out into the field, set it up, record everything on the log sheet, and begin their measurements. We can set up the position measurement intervals, also a position interval. If you thought that it was going to move or anything, you can do for different applications. We can also log a few other things, like say an SBAS feed. So if we wanted to know the complete satellite based correction feed coming in, we can log that at the same time. And also look at how we can set up the path style, so where it's going to load into, and also whether or not we're taking the serial number in full, and then year, month, day, hour, minute, or just a truncated version. At the end of that, you can also configure that it would push it off with the, if it's online all the time, with the, let's say, R10 or R12 receivers. They all come with a little short stub. You plug it in and put a USB stick in, and it will dump all of the logging data onto that USB stick. Once we have logged, then we come into internal. If we've got logging files in here, then we're just able to select those and download them to our PC, or we can choose to convert them to Rhinex in this interface as well. So there's a little bit of processing that can occur in here. Now for Trimble Access, let's jump into this. Let's just do a new project. I'll call it GNSS. Okay, so setting up our job, but what I really want to do is jump into the settings and the survey styles. So within here, we could create a new survey style called static, make sure it's a GNSS type, and accept. Now, for static surveys where we're starting it from a controller, I would tend to connect it as being the base when doing this. And in Access, we call it fast static because we generally wouldn't be setting it up in this way for, let's say, really long occupation periods. It might be the fast static, which is kind of up to about 20 minutes to an hour. You might classify that as. Within here, we get the, let's put it on R12. We can leave that blank so that we fill it out when we set up. You could configure this to have a serial number, so that gets pushed in there as well. Now, we would always want to log to the receiver because that means that we get all of these satellites constellations available to be logged at the same time. We can set up the logging interval, any elevation masks that we want. We can go down to 0 on the base when we're setting it up in here, whereas when we're doing a roving survey, you wouldn't be able to set this below 10 degrees. And once we've got this set up in this way and accept, then it's just a case of going out to the point, clicking to get it to start, and start survey. So really straightforward, nothing to it particularly, but another option there. And that complements the base files that we could add some extra information in our Trimble Access job. You can take a photo with the controller, you can add some notes, anything that you would normally do with Trimble Access. Okay, so jumping into TBC. Just call out with any questions along the way if you want as well. All right, I'm going to start off a new project and just select for metric. One thing to be aware of in here, when I've run the installer for TBC, I've selected English UK rather than English US, and that means that I don't have the US survey feet templates sitting in here. They are able to be deleted, but just by selecting English UK, that doesn't load them. So that makes it a little bit easier in that regard. So I'll set up for metric. And first thing we'll do is jump into our project settings and define our coordinate system. So at the moment, we're just on default using global coords from WGS 1984. And we're going to update this to be GDA 2020 in zone 55. Okay. We'll just check because sometimes I have this a bit quirky, and I'll jump back to 3 decimal places. Okay. So nothing in here yet. I've got a file here that I've prepped for training sessions like this. It has been generated from the cores network. So the baselines are quite long, but in this training data set that I'm going to be running through quickly today, they're relatively short. We're only dealing with a 1-hour session on one day and then an hour on the subsequent day to make the processing quite quick for going through in a short format. I'll just jump to here. TBC tutorials, where have I put them? There. They have quite a good tutorial called GNSS baselines, and it will run through from end to end, similar to what we're doing, with a canned data set that was an actual survey in the US. So that's a good one to have a look at as well, and work through. You'll get a lot of content out of that. There's always lots of learning to be done on the tutorial side. Okay. So what I've done with my static files is I've split them into session 1 and session 2. We would be able to see this in the raw data check-in, and I'll show you a little bit of what I mean. So I'll grab all of these and drop them in. So this is the receiver raw data check-in screen, and it provides the point ID that's embedded in the logging file. It also gives me a start time and a finish time. If I'd put in some observations from the second session, then we'd be able to see these quite easily in the start and finish times. We can see the duration. In this case, they've been logged for an hour. So within TBC, we could utilize a service called RTX post-processing. RTX is a Trimble product. It stands for real-time extended. And in the field, it allows you to get a correction feed without a base. It will get the corrections from satellite. So it's a paid subscription for in-field use. And for a lot of very remote applications, let's say we're doing boundaries in Central Australia where a couple of centimetres is pretty appropriate, then RTX center point, real-time in the field, would be quite a good solution for achieving those rather than something like a static campaign. In the post-processing, we offer that service free. If you go to put in the information through Business Center, because Business Center is gearing this to want a survey deliverable, then it has a filter to only accept sessions in excess of 1 hour. And I think there's a time limit that they don't go above 24 hours either. But if you go direct to the RTX PP website, you can load in shorter logging sessions and still get them to process. It will just be a balance of how short you can go without deteriorating the results to outside of your survey tolerance that you're trying to achieve. So a few tabs on this check-in screen. We've got the antenna, so we can see here that these are all measured bottom of antenna mount. Only one of them had the serial number recorded. These have all come from the cores sites, so they basically they don't have a point that they're being measured over the top of, so this is appropriate for where these have come from. But we get a bit of information about what type of receiver. In this case, we've got all Trimble Net R9s. So I'm happy with that for session 1. I'm going to click OK and accept to bring these in. And here's my first set of static observations. Something that I like to do just to validate what's going on and have a bit of a look at is just down in the bottom toolbar, I toggle the background map. Now this will cache and feed the map view into the screen here so that I can have a look at where these were logged from. Now, as I mentioned, you can see here we're at a scale of 20 kilometres down in this corner. So these are quite big observations that we're dealing with, but it was just to build out a data set that was relatively easy to work with. But if we zoom right down and in, this acts as a nice way of looking at whereabouts these were positioned. And what I can do, because sometimes from a dealer perspective, you'll get information that you don't understand why it's not performing in the way it should, and just validating where these receivers were set up using the satellite view as well can be quite helpful. You might find that it's in a highly obstructed position and that the results that are coming out line up with the position that the receiver was in. Once this caches, we'll see that this one, like most of the cause sites, are set up on top of roofs to get out and away from any local effect, and multipath to give the best possible satellite tracking. But quite handy to be able to jump in here and see its real world position without going out to Google Maps or having a look at anything else. Okay, I'll switch those off for a second. Now, one thing that we can see here is that when we have loaded in this one session with, what have we got? 1, 2, 3, 4, with 8 receivers, we've got quite a lot of baselines, and really we shouldn't, it's best practice not to process all of these baselines, because what we actually have is a thing called a trivial baseline. So I've brought up just in Paint here to explain this concept. If I was set up at here with a total station, just stretch that out a bit, yep. Set up it here with a total station, and I was shooting to a prism here and a prism here. Raise this out of there for a second. Okay, then when I'm set up here, I make this observation, I only have 2 vectors. But if I'm doing the same thing and occupying 3 points with GPS, we also begin to get this vector coming in. And we refer to that as being a trivial baseline. There's a few different phrases for it, but basically it's information that isn't required to figure out the geometry of these 3 points. And what it does, it influences our statistics. So when we're making an assessment of our network adjustments, this shows incorrectly as more degrees of freedom, so more redundancy in the network. So the practice is to remove these, and whether you chose to remove this one or this one or this one, it doesn't particularly matter with GPS. One of the things that you might be looking for is a lower, better results in the baseline processing, and you could assess which ones you keep from that. The easy way of doing it is just looking at what the longest baselines are. So in this case, we've obviously got one coming through from Woori-Yallock way up to Marysville, and it is, we can see the baseline length in here somewhere, I think. Maybe not, I'll just do measure. I won't do measure with that because it's overlapping my menu. Measure from here to here. We're looking at almost 180 kilometres. So it wouldn't be our best case of processing that. There is a diminishing amount, diminishing result that you achieve with any GPS, and that's usually correlates to an additional 1 part per million, so a millimetre per kilometre, and we would be adding in about 180 millimetres potentially in that processing compared to like a baseline of 1 kilometre long. Now, in pre-planning this, I had created, I'll just jump to here, a little session diagram. Now, don't treat this as a how to survey. This is just how to use some of the tools in TBC. And what we have here is how I want to configure my first session. So these are the baselines that I want to retain. The amount of baselines that we retain, if we've got 8 receivers, then we should retain 7, because the amount of receivers we call N in any one session, and the amount of baselines that we should have to achieve a statistically accurate model is N minus 1. So whatever the amount of receivers are, take 1 off. That's how many baselines you should leave for your session processing. If I scroll down through here, this is a combination of the 2 sessions as we want to see them once I've worked on this. So what we'll do is we'll jump into here, and we can either choose to disable these, just say disable baseline, and in our view filter we can say I only want to see enabled baselines. Makes it a little bit easier to go through these and disable them. Disable those baselines. Here. Have to update the graphics sometimes. Then I have to check what my diagram said. So we make that shape, that one, and that one. Okie doke. And with multiple sessions, we always want to achieve, where we can, observations between each of the components as well. So in one session, we might achieve the absolute best possible outcome for short baselines or good geometry. And then in the second session, we'll have slightly different geometry just to try and build that redundancy between stations as well. So disable, get rid of that one, disable, and these 2, disable. Okay, so we can see what I've got there. Let's just check back to our little diagram. And we had Marysville to Kyneton to Gisborne to Bacchus Marsh. And we had Kyneton to Whittlesea, up to Kilmore, down to Woorolloc, across to, that one's Marysville, that's one Maryborough, right? Okay, so that looks right. If we wanted to see this in a different context, we can also look at our time-based view, which allows me to see the entire session length and where we had different receivers at different times. This will make a little bit more sense about looking for sessions once we add the second one in, and when you look at a tutorial data set or a little bit more real-world example where the sessions are back-to-back and there's no gaps in between. It's quite handy to be able to see this. We could also then flip what we're viewing on screen. Let's say we come back to here and we say disabled baselines only. If we're never going to process these, we could delete them as well if we didn't want them. For now, we'll just leave them disabled, and that will allow us to focus in on what we want to see. Okay, so what we can do here, we're on session 1. We can choose for process baselines. This will automatically start, and it runs through and processes these. Now, we can, from this menu, automatically jump to the project settings as well and have a look at some of the settings. So the general settings we see here, most of the time I wouldn't change these. There are instances where people are chasing higher order accuracies and might want to look at different models around what they're going to be processing against, but most of the time we can just leave this. We should have all satellites on. In some of the earlier versions of TBC, at the moment I'm operating version 5.2, we default all of the satellite constellations to be on, so they're all for processing in that regard. We also automatically process at 10 degrees. There's some discussion around whether that should be higher or lower, depending on which country you work in. I've heard of people raising it to 12, and in other instances dropping it down to about 7.5 degrees as well. So I won't make comment on what you should or shouldn't be doing, but that's up to you and what you are trying to achieve. We always want to have fixed solutions here, and where we can, we want to run all frequencies, so that if we did have an older receiver that might only be getting dual frequency, it will process both. If we've got a newer one on all frequencies, then we make benefit from that as well. For the high-end GNSS processing people that want more out of this, then contact your local distribution partner, and they can have a chat to you about custom ionospheres and being able to access some other things in this menu. Okay, I'm happy with all of that. I'm just going to hit process again because I abandoned those changes. And what we see here is the precisions at 95%. We can change how these are being reported, whether we wanted to see them at 1 sigma at 95% or 99% confidence intervals. Generally, we run this at 95%. It's the industry standard. So nothing outrageous in here, given the length of the baselines and also the length of the occupation periods. We do get some flags here because the points that the logging files that I brought in also have the known government published locations for them. So they do a broad scale adjustment, they publish those, and most of the time they're embedded into the logging files that you might download from the web. So because we have a lot longer period and better network adjustment information that's holding those positions fixed from government, when we do our relatively short occupation period over a reasonably long baseline, we start to have a little bit of a conflict where the error along this baseline is conflicting with the positions of these points. And if we have a look at our little error flags window, it says that it's 22 mil out of position. Now, generally, what you would have occurring here is that you might have a couple of control marks, not all of these being control marks, because you would have your internal network you're trying to establish and then your external control network where you're bringing the coordinates in. And if we were to treat this in the same way, we could just take this position and make it an unknown. Similar to the others as well. We should really be doing that with this one. Treat this as unknown as well for now. Gisborne. Should figure out a way of doing this before we jump on the call, but anyway. Easy to see the process here. I'm just going into the properties rather than the properties of the point itself. So in this case, I can bring up the properties of the point, and it tells me a bit of information around its coordinates and what it is. But if I go to the actual coordinate entry for that point and bring up the properties, then I get some blue text. I could override what's been entered here, but what I'm going to do is just override the hierarchy that it sits in within TBC so that it's being treated with a lesser priority and we're not trying to constrain its result. So now I'm saying that Maryborough and Marysville are our two state control marks, and we're establishing a network in between these. So if I just click F4 should reprocess. Clear the processing. Okay. Still get a little bit of error along this one, where there's some form of problem in there, but nothing too major. Okay, so that's the first session process. Now let's bring in the second session. I mentioned the RTX PP. So if we do it through here, we send it off to our online processor. As a similar concept, you would say that AusPOS is offering a service like this, but using different computational engines in the background. There's a few others globally like Opus that offer a similar service as well. If we were to go to the online portal and log the data through that, we get a slightly different report coming back. So if you wanted extra information, rather than just a position coming in and a little bit of metadata from it, then using the online portal does provide a report as well as the information. Okay, so these are fine. These are my second session. And it comes back in and it looks a bit of a mess again. So what we can do in our view filter and observations is that I want to look at unprocessed baselines only. And I don't want to show my post-process vectors. All right, we've got an extra point out here that I didn't want. So I'm just going to delete that. And that cleans that up a little bit quickly. Because I've brought in new points again, what we've had happen is these have reverted back to being control, because in those logging files, they're actually coming in with control quality coordinates embedded onto them. But we could remove those. We could still network adjustment and just not treat those as control. Any flags that we're seeing down here, it's not telling us that it's going to disrupt the project. It's just making us aware of a computational error, and we can choose to ignore it once we've seen what it is. Okay, so for my second session, I come down from there to there. I go zigzagging through there and up. So I'll do that for session 2. One thing we can do here is, now that we've got 2 sessions, we can see in the time-based view, all of these are currently enabled. We've only got a few still enabled on this side. The rest have been disabled. And that correlates to what we're seeing in the map screen. So again, I'll just come in, disable. I want to get rid of all of these ones. Disable. Really up to you whether you delete or disable. There's no, I'm not going to say there's a right or a wrong way to do that. That's user preference. Let's count these up. 1, 2, 3, 4, 5, 6, and 7. Okay, so we've got the right amount of baselines again. If we just jump into our time-based view, we'll now see a load of disabled baselines for session 1, session 2. These obviously get more and more complex as you go through and have multiple sessions on top of each other. So one thing you can do is run multiple TBC projects. So you could have a TBC project for each session, run your processing of an individual session just within each of those projects, and then use this to merge survey projects. This function was written a little bit around complex GNSS processing and merging in the survey information. It wasn't written to merge in everything that's contained in a TBC project. So you wouldn't see scan data coming through or IFCs that have been loaded in as a reference. It really is a subset of information that's being used in that merge survey project. And just using F1 and navigating to merge survey projects, it will give you some detail around what is and isn't supported in that. So I'm going to let this process again for the second session. Let's run this. There are still 2 unresolved computational errors. Yep, I'm okay with that. I understand what they are, and I want to continue. Okay, so we're getting pretty good results. Nothing outrageous in here for the horizontal. It's what we'd expect for a network like this, being set up this way. And we'll click OK. So I had turned off the PP vectors because the way that I've set this up is I only want to see the unprocessed baselines and the ones that are enabled. So if I put on processed, there I get all of my baselines back on. And if I then click on PP vector, I put the vectors over the top. And when I click, like with most of TBC, if there's 2 things within the actual pick box, then it will come up to say, did you want to select the baseline or the vector? Once we do have the vector, we can bring up here and it gives us a little bit of information just on screen around the processing here for what we saw in the network processing engine, GNSS processing engine. One thing I didn't do here was the report. So I can just, this is going to be annoying, isn't it? I'll go baseline. Report from this window. Where are we? GNSS process report. Find a good way of getting rid of this little thing at the top because it really makes it difficult to navigate your windows. Okay, so after we've done our processing, if we wanted to see more information than just what's shown in our first window, we can bring up the baseline processing report. I've just run it for this single baseline that was in selection here. So it's the Kyneton to Maryborough. It tells me that I've got a fixed solution, the precision's at 95%. It gives me a geodetic azimuth, ellipsoid distance, and a difference in height from one end to the other. It processed, it passed, there were no flags or fails because it fell within the expected tolerances there. At the moment, we're using the broadcast ephemeris and the NGS absolute antenna model. I collected the data with 30-second observations being requested, and processing duration was almost 1 hour. As we jump down through here, it gives us information about each of the points and the standard errors associated with them. And then as we keep going, we get a tracking table of what they were tracking and processing. And then we get residuals, and I believe we get down into gives us a little bit of the processing styles at the end of what we had set up in our project settings. And what our acceptance criteria was. So on the first page where we said that there were no flags and no fails, it was because we were looking for these particular acceptance criteria, and that can be refined to try and find bad baselines if you want to, and by cutting these numbers down. So in the acceptance, you might want to change this. You could also, I'll just close out of that, back to here. Where are we? Quality. So we could cut these down for flags of pass and fails, and we can use these optional ones as well, looking at the RMS values for dual frequency. We are a pretty unique package in processing L1 only signal for GNSS baselines, but that's really a very limited application these days as well. Okay. One other thing we can do when we're trying to check through this data is a loop closure report. And what this does is it will process the loops around, so connecting geometry of baselines. And at the moment, we really don't see much other than the number of loops and that they all passed. What we could do, we just need report options. Now that report was the loop closure report, and what we ask it to do, report settings, we can ask it to show past loop sections. Show, so when they pass, these will also be displayed. So if we rerun this, we now get our past loops giving us information around each of these loops. So you can use this as well to try and fault find in your GNSS processing. So in this case, if we wanted to have a look at this, we click on it and jump back to TBC, and it actually shows us and hyperlinks. One of the really good benefits around these reports is that they will hyperlink back to TBC to make a selection. So if you wanted just to select a point, come back to here, and it's made that selection in the TBC interface. That's consistent for a lot of the HTML reports that we generate, so just one to be aware of. But if you're doing public deliverable, or I guess for part of a project, then custom reporting is quite a powerful option where you can generate reports into Word documents with your own business header and only extracting the information that you really want. There's a subset of reports that support that, but one of those is the network adjustment report. So now that we've processed this, what we would be then jumping into is the network adjustment. So at the moment, I just want to see what's occurring in here without influencing it in any way. So for my standard errors for GNSS, I'm going to be bringing those from the baseline processor. If we have a look at GNSS, the other aspect that we deal with is the centering errors. Now at the moment, I don't want to influence my results by putting in a centering error here. I'm just going to keep it clean and to say that everything was exact. And then I can add these in before I generate my final processing of a constrained adjustment. So that looks fine at the moment. We'll go to Adjust Network. In this interface, this is where I can lock any stations when I want to constrain them. So this would lock their 2D position. This locks their ellipsoid height, H for ellipsoid height, and E is for elevation. When we do get to the point of locking these, we shouldn't ever lock a combination of ellipsoid heights and elevations or orthometric heights, because that it creates a poor least squares adjustment sort of constraint, where we should either constrain one or the other and just stick to it really. So if you're dealing with AHD derived heights and spirit leveling, as well as the GNSS two-dimensional positions, then pick out which ones you're going to do. Don't do a combination of the two. Okay, so I'm just going to run this as is for the moment. Yes, I've got some errors. That's because of the constraints that exist in there. Now, on this menu, we can see our results. We get a reference factor of 0.42, and that's indicating that our network has performed better than our estimates thought it would. So we're actually getting a result that's inside of our error estimates. This chi-squared test is a test that indicates whether we're closely achieving a reference factor of 1. So it's a test just to give you some understanding of a yes or no. Is it falling too far outside of above or below a reference factor of 1? Now, This doesn't mean that it's a bad network adjustment. It just means that the error estimates we've fed in at the moment were larger than the errors that have actually been produced from the adjustment. So that's the a priori estimates are larger than what we've achieved with the a posteriori estimates. Degrees of freedom at the moment for processing this network, we have 21 degrees of freedom. So that means we've got 21 observations that are redundant to actually achieve positions on all of these stations. If we had included all of these baselines as well, where we've disabled, I'm not going to count them, but quite a lot, then our degrees of freedom would be up at about 50 or more, or 60, if we went through and counted, because all of those additional baselines would be influencing that, which can then also knock-on effect to change your reference factor and give you a statistics that don't add up to the real world. When I'm in this results screen, I can just click on an individual point and see what the errors are, and these are reported at 95%, because that's what I've got in my project settings at the moment. So we're also giving it, and we haven't locked anything. The points that have been created here from the logging files have a latitude, longitude, and ellipsoid height. We do provide some information around what the elevation error would be when we do this as well, so that if you're locking it from leveling, then you also get that in there. Now, we look at the weighting screen. What this is for each of these individual components that have been broken down in here, and we're only processing one component, these post-process vectors, it is just a scalar that's applied to the a posteriori estimates back onto the a priori, so that when we reprocess, we start to achieve a reference factor of 1. And you'll see that the these estimates carry out in the network adjustment report. So we could apply that, come back to here and click adjust again. And what we see is we start to achieve a reference factor of 1. So we've modeled our network better. We've passed, we've still got the same degrees of freedom. What we really should do, if we're doing a lot of the same type of processing and we find that the reference factor is always coming out too low based on the processing engine, what we could do is, instead of getting the source for standard errors from the baseline processor, we could change that to be coming through from these default standard errors. So for instance, I'll come back and say I want to use it from the project settings, and I want to reset these scalars to 1. So we're not applying a scalar, and we are going to rerun the processing, and rather than using the GNSS baselines as the error estimate, we're just using the fixed project settings that I've keyed in or taken from the default. Okay. Now you can see the default project settings are very, very loose, because now our reference factor has come way, way down. So if we have a look at this, for the horizontal, maybe we should be, let's say, just to demonstrate a point, don't take this as gospel, and I'll just readjust. Did it actually take note of that? Reset to 1. Clear adjustment. And adjust. No, we're still not getting down to where I thought we would on that. just try this for a second and see if it will do what I'm expecting it to do. There we go. Okay, so just an example of how you can change what's occurring here. So if you are finding it's a consistent amount, then you can model your projects to reflect what your survey styles are doing for your occupation periods, the types of receivers you have, and what's occurring there, so that you more quickly achieve a reference factor close to 1, that you've modeled things where you expect them to without having to apply a scalar each time you run this processing. Okay, so that's an unconstrained adjustment. What we would then move into is the minimally constrained and the fully constrained adjustments. Ross, do you want me to run into that a little bit, or will that be covered in another session?
At this stage, I haven't got another session to cover it, so if you want to keep going through and you've got the time, then we can cover it. Is that all right?
Yeah, I'll just go through it quickly.
Yep, do that. Thanks, mate.
Okay. All right, so what we can do now, I'm actually going to change the processing settings back to from the baseline. I'll leave the centering errors at 0 for the moment, but I'll clear my adjustment. So back to scratch, where we would normally be. Now, within this, we can start to constrain things. So as I mentioned, we're treating this section in here as being the network we're establishing, and these two markers on the outside as being the state government marks. So we want to start by just constraining one of these. So that is the Maryborough, and we'll constrain it for 2D and height. We have a little interface here to put in some standard deviations for the quality of these positions. I'm going to leave it as 0 for the moment, just to make sure that that position doesn't move. But what we are going to do is we would then enter what the state government says this particular coordinate is known to, its quality, so that then our error ellipses reflect the same thing if we were to report back to the government that we've established a network with this coordinate at a 95% confidence interval. So, and let's say this, depending how we wanted to do it, you can add things like azimuth constraints, and it just allows you to pick from and to, go to Kyneton, and as I hit tab, it automatically populates, and we say that that's going to be fixed. This isn't being used to rotate surveys by 100 degrees. It's being used as you would use it in a least squares adjustment, where it's a constraint to give it a particular direction so that the rest of the network, you can't see me, I'm always talking with my hands, but isn't going to swing around. So it's like one of my lecturers explained it, you take a piece of paper and pin it onto a wall, it's going to freely swing. You've only put one constraint in there for the initial coordinate. You need a second pin to be able to control that azimuth of the direction that it's being swung into. This could also be from constraining the secondary point out there. Just trash can that for a second and just hit adjust. Okay, so we see simply by fixing one point, we start to skew our error ellipses a little bit. The reference factor in this case, because we've gone back to the baseline processing engine, is still at 0.42. So we're not seeing anything untoward occurring when we start to perform this processing. Depending on the rigor that you want to apply to your processing, then at each processing step, you can generate a network adjustment report, and you can save that so that you've got each step documented to show each of the adjusted observations, the residuals, and the estimate at the end, as well as making comparison with standardized residuals for distance and angle azimuth. Okay. So then as we continue on and keep on constraining, then we would begin to constrain this. Now, because I'm constraining a position here and a position here, I'm not going to add in any azimuth constraints. The entire network is going to be fixed via the geometry between these couple of points as well. Okay, I'll hit adjust. Again, we see the shape of the error ellipses change because of our constraints changing. These points are no longer allowed to shift. They're being locked, and the rest of the network has to move to accommodate that. Our reference factor actually comes back a little bit closer to 1 now because we're taking out some of the problems in there. The other thing to note is that our degrees of freedom has now gone up because we've locked in 2 positions where we don't need the geometry to establish these. Then we now have more redundancy in our network within what we're processing. If we have a look at normal, and we'll see we're getting east, north, and elevation. These errors have increased slightly because now we're not distributing the error across these points out to the ends as well. We're now only able to distribute our error within what we'll call our network. So we haven't seen anything major pop up here in terms of blunders at the moment. The final step in this would be to give these their real world errors. So when you search government marks, they'll generally be supplied with a quality for the actual mark itself. And that for Victoria is done through Survey Mark Inquiry Service, for New South Wales it's SCIMS, for Queensland I think it's Queensland Globe, and then a few different ones around the rest of the country. And LINZ in New Zealand would have it. In TBC, we're actually asking for the horizontal standard deviation at 1 sigma. It is standard that we report, or the ones that I've seen for government marks are reported at a 95% confidence interval. So in order to get back to this, we need to divide the error by 2.448, and that gives us our error as a 1 sigma value. I haven't got the survey marks on hand, so what I'm going to do is just key these in with some numbers so that we see what it does to our error ellipses. So I'll make these both the same. And we're going to now readjust. So our reference factor changed a little bit because now we're giving it some information around the actual the errors at these points. And if I click on Kilmore, we'll see that our errors have now gone up quite sizably. So from 4 mil up to 13 mil. And that's now reflecting that within the state network of this point being known to a certain amount, that we're on the same page with this one. If we were reporting this back to the government to say we've established a network, these are the points and these are their associated uncertainties, then this is consistent with how this would be reported. The only thing I probably neglected to do was just on here. In this case it's cause, but you would expect some sort of centering error and height error, depending on the tribrax used, the method used, how you've been doing your height, if you're using a tape or that might bend, or an actual GNSS measurement rod, like what can be purchased for the Zephyr larger antennas, the geodetic antennas, to make those measurements a little bit more accurate. Changing that, we see a little bit of influence into our reference factor. We would apply the scalar value, reprocess. Okay, we've got 9.7, we've got a pass, we've got 22 degrees of freedom, that's all staying where it should be, and these are now reflecting the error. Now that I've given it a little bit of tolerance around the centering errors, we also impart a larger error onto the points themselves because there's more uncertainty into that network now. There, as well as the network adjustment report, we do offer this relative tolerance report. So it's been given the title ALTA NSPS, which is American Land Title Association. It's consistent with what the ICSM recommend in their SP1 document for relative tolerances, and it allows another way of having a look at these. So I know in New South Wales it's being used slightly differently from an older ICSM SP1 document. I think they use version, if I bring it up here, is version 2.1. They're using version 1.7, I believe, which uses a class order way of looking at the relative tolerances rather than a constant and scalar, which is current practice for ICSM, the way that they would document, which stacks up to what we see globally as well. Okay, and what this does is it compares the precision tolerances between 2 points to give us an understanding of how they work together in that network. So from one point to another, over that distance, with that precision, what would be allowable, given I've got this constant and scalar. So we're saying that 20 mil plus 50 parts per million, that's pretty generous. We might actually want a better network than that. We might want 10 mil, and we only wanted an extra, let's say 5 parts per million. So now we start to look at this and we come down to a much smaller allowable precision over that many kilometres. And even that's relatively generous. So you tailor this to what you're trying to look at, and it's around just being able to find the problems in the measurements in the data set, and then reporting back in a way that allows you to make sure it's consistent with the government standards that you're adhering to. So that takes us through, I guess, a quick version of baseline processing and some network adjustment. If you keep an eye out on the UPG SciTech website for their April mega month of training and on into the future, we'll be running more of these. And also, if you have a look at TBC YouTube, it's called TBC Survey and Construction on the YouTube channel. They have a number of different pieces there, as well as our webinars. So if we go to Power Hour, just from the support tab, we have actually done a lot of these before on GNSS processing, and we are currently rerunning some of these and then opening it up for questions again. So it might be the original webinar that's being run, but then the people that presented it originally are on the line to take questions in real time as well. So something like this, where it's TBC recap, static GNSS, and baseline processing. So we've had a session like that in the past, but we're just recapping on it to provide that and give a platform for people to ask questions around again. Okay,